Welcome to The Bunker and my first YouTube video, hopefully one of many covering topics from broadcast, electronics, reviews and stuff that happens in my life. Hit subscribe if any of these topics are of interest, and this is my first video which is my experiences with the Hyundai HY1000SI portable generator.
Hyundai generators are inverter driven, which means the output is cleaner than mechanical generators. They're designed for use with sensitive electronic equipment. There's an eco-friendly switch where the generator will cut back its speed if you're using a low-powered item such as a laptop, and it'll speed it up if a high-powered device is attached, like a drill. This also saves on fuel as well as cutting emissions and noise. So all of this looks ideal for me, and I picked mine up for £370 new. Jump forwards less than 2 years, and here is my generator in its current state. That's not ideal at all, is it? I'll run you through a brief history of how it got to this stage, but it's not an exciting story. In fact, it's pretty uneventful, but it's useful to know because I think many of you will have the same usage patterns and you'll want to know if your generator will work when you actually need it. I'd not used my generator for more than maybe 10 hours in total, perhaps just 3 tanks of petrol, and it had been kept in dry storage. I tried to start it up once in a while to keep it going, make sure nothing had seized. In fact, I had a low-power kettle that I'd make a cup of tea with, just to prove it was happy on a load. And generally, it sat around not being used, and mechanically, it's in perfect condition.
And it was one of these test days that I struggled to get the generator to start. Now, I'm no expert, but I know enough about engines to realise that there was no spark getting to the spark plug. So at this point I called in my colleague Paul, as basically there's nothing he doesn't know about the internal combustion engine. Now Paul took a look at it and he diagnosed the problem being the CDI.
This is the CDI. It takes low voltage pulses generated by the engine turning and amplifies them. Makes them more spiky, I guess. Those spikes then drive the spark plug to ignite the fuel. Once the replacement CDI arrived, the engine started instantly. But there was a problem.
Unfortunately, I don't have any footage of the dramatic moment that followed. The engine revved wildly, like a boy racer at the traffic lights, and the generator didn't seem to want to stabilise at all. And then suddenly it sped up to an extreme level, there was an electrical crack noise, and one of the large capacitors went pop. There was literally smoke coming out of it. In revving up, the engine had reached too high a voltage for the inverter, and that caused it to fail. Annoyingly, it's always the expensive parts that go pop like this, but I ordered another one, and here's what happened next.
The replacement inverter has been fitted, but as you can see, the engine still wouldn't settle. The throttle is still fluctuating. It's driven by a small stepper motor that is in turn controlled by the inverter board, and it should increase the speed of the engine based on power demand. But with nothing plugged in, the revs just wouldn't settle to one level. Could the stepper motor be at fault? Paul had a handy stepper motor tester, which we rigged to the motor that drives the throttle. The positions all corresponded, and you can see it stepping bit by bit and eventually doing a clean sweep all the way through with no problems. So it looks like it's another faulty inverter board. Fortunately, the supplier agreed when they saw this video and they sent out another. Looking a little closer at the inverter board, you can see that everything is encased in resin. Now, the idea of the resin is to prevent vibrations from the generator causing components or connectors to work loose. But unfortunately, this also means we can't reverse engineer the circuit to find out why these boards keep failing. They've become a non-serviceable part, and the only cure is an expensive replacement of the entire board.
Now, because this is also the brain of the generator, there's a lot that could go wrong. A replacement unit costs £200, but when you look at a new generator, it's £370. You've got to weigh up the cost and importance. Now, I'm stubborn, so 200 quid is still less than 370 quid. I like the features and the size of the Jenny. It's kind of a case of better the devil you know. Anyway, the replacement second part arrived, and I hoped that this would be the final chapter in this sorry saga.
Of course it wasn't. This is the stepper motor you can see now removed from the throttle, and we've set the throttle manually. So with a manual throttle the engine stays steady, but as you can see the inverter board is for some reason telling the stepper motor to keep stepping round. Why? The only explanation is this third inverter board is also faulty. The supplier admitted this to be the case and offered a refund.
Now, it's worth mentioning at this point that these generators have been redesigned in 2016. Now, I'm not sure if the electronics have changed, as Hyundai seem very cagey releasing service manuals and circuit diagrams. And I see that Hyundai are also offering a 2-year warranty. And I wonder if they've realised the volatile nature of their inverter boards and perhaps addressed this. Either way, both these changes were too late for me, and I'm left with a 370 quid generator in bits that's useless. I hope this helps you make a decision whether to invest in a Hyundai generator, and perhaps in future video we'll try getting into the inverter board to see why they fail so regularly, and perhaps even consider designing a replacement. That could be fun. Click the thumbs up if you like this video, and please do subscribe as well, and hopefully see you soon.
Yeah.